As you can see, 17 seconds per iteration. And the most important thing is that almost 5 GB are being used. Let's try to increase the resolution not to 1000 but to 700 pixels. Let's see how this affects the video memory load and the time for one iteration. Apparently we have landed well again, because the number specified after the words loaded partial is approximately the same. And the speed, yes, has decreased. This is probably due to the fact that the resolution is more, but as we can see, video memory is being loaded more. That is, in theory, everything is normal. Let's try to generate an image at 800 pixels. Let's look at the video memory consumption. That's why the number written after loaded partial has decreased. 3400 megabytes, even though there is a whole gigabyte of free video memory. The question arises, why is it happening? We have free video memory. Well, intuitively the loss is not that big, about 10% in time. Therefore, let's try to increase it to 900 pixels and then to 1000 pixels. Let's see how smoothly the time increases. Let's try 900 now. Let's start. The text encoder processed. The key sampler started working. Requested to load Flux. 2900, even less. Video memory is being used very little, currently 4500 megabytes. In the previous time, the increase in time was from 34 to 37, with change 100 pixels. We expected it to be around 40 seconds, but actually we got much more. The memory increase is visible here, about 10%. Here we have 2900 and 3005, probably it's higher here. Why is that? And there is still free video memory, another 1300 megabytes. What's the logic? Let's stop and try to change some launch flags to figure out how this logic works. Let's try to figure out it out. Let's try to disable caching immediately. Ideally, it should not affect anything, but let's try. Now I'm running ComfyUI with disable smart memory flag and with cache known flag. Let's see how much video memory is being used now. During the loading of the main Flux Schnell Q2 model, it loaded completely, the clip encoding processed, and now the Flux is loading. The same 2900 megabytes, that is, these flags have not affected. Let's try some other flags that we find. I have looked through various recordings about ComfyUI. There are some other flags: high VRAM, no VRAM, normal VRAM, low VRAM, no reserved VRAM. I have left the disable smart memory and no cache flags as well. Logically, there is either not affecting anything, or they are more for experimentation than actually. Let's start immediately. We have a 900 pixels resolution. The text encoding models are loading. 3800 megabytes memory loaded. They are processing. Okay, that's great. What are we seeing? There is almost no free video memory. and the full loading of the model into video memory. At least loaded completely is written. 5600 megabytes are being used. Now let's look at the generation time. Then we will try removing the flag. Disabling caching. 56 seconds. 56 seconds. The same 56 seconds. Interesting. So the model apparently has fully loaded into video memory, but the speeds have not really increased. A question arises: is this flag worth leaving or not? Will there be a situation in the future because the model is not loaded into video memory on the graphics cards? Will there be some slowdown somewhere because of it? On the other hand, if this flag is not enabled by default, there must be some troubles. When there is not enough video memory, perhaps ComfyUI will simply interrupt its work without any errors. A crash will occur. We will try removing both flags and disable smart memory and no cache. We will leave high VRAM flag, temperature 61 degrees, undervolting was performed on my card. Consumption of the video chip is limited at a level of 0.9 volts using editing of curve in MSI burner. That's our yellow car. We are removing the flags, smart memory and cache known, and we are trying to run it again. We are starting. Let's see how much video memory will be used. For the case sampler, the text encoding 3800 so on the text encoder, and now the Flux is loading, full loaded completely, 3900 memory used. Video memory 5500 megabytes. Therefore, in this case, the entire model is loaded into video memory, which is what we needed. Okay, today we successfully completed work with Flux Schnell Q2 on the NVIDIA P106-100 graphics card. And by the way, an interesting message. Warning that a memory shortage error occurred, more precisely a warning when the VAE decoding was working. That is an interesting point. By the way, let's try to 1000 pixels resolution. Excellent, caching worked. Immediately we started the Flux model. As you can see, everything is again loaded completely. In conclusion, today we launched the flags for the model, specifically the Q2K Flux Schnell in the gguf model. We tried disable smart memory. We tried high VRAM flag. We tried cache known flag, and we realized that in general is not entirely clear. Even if it's greatly loaded partially, meaning the model was loaded into video memory partially, and there is still an amount of free video memory, the speed is still not that good. So there is still something to think about, to experiment with. Write in the comments how these flags work, because we have practically tried them almost. Theoretically, according to the documentation, what is written there? Well, interesting. How these flags works and why generation speed did not change. We did not have a win when we loaded model into video memory. About 50 seconds at a 9 pixels resolution with full loading, high VRAM when without full video memory loading. Same 50 something seconds. In conclusion, let's look at the whole format yellow car on a green field in the forest in HD resolution. The video card temperature is 65 degrees. Again, we have a warning. Nevertheless, VAE worked. What are we going to do next? Let's try the Flux context. Changing pictures. Let's load that model onto 6 GB of video memory. Then let's try to work with the separation of musical files, musical tracks, into components, drum separately, bass separately, vocals separately, and so on. Let's see the speech recognition with translation to English. In the future, we will need to run video generation. For today, that's all. Write in the comments or make a video of it, or tell us your opinion how these flags are working according to the documentation.